Hello everyone, welcome to Algebra 2, Lesson 1. Today we'll be going over polynomial expressions and equations. So for this video, I had a schedule of what we're going to be doing. So number 1, we're going to be doing polynomial arithmetic. Number 2, polynomial factoring. Number 3, the remainder theorem and the factor theorem. Number 4, polynomial equations. Number 5, quadratic graphs. And number 6, polynomial graphs. So starting off with number 1, which is polynomial arithmetic, we'll be learning how to multiply, divide, add, subtract, anything you want with the polynomials. So this is the first subtopic, multiplying a polynomial by a constant. So a polynomial is an expression that combines numbers and variables raised to different powers. Example, x squared plus 3x plus 2. So in order to multiply a polynomial by a constant, you need to multiply the constant to each of the coefficients of the polynomial. It's also known as distributing. So we have 2 examples here. I would recommend you pause the video, try them out, and we'll see them after. Okay, so example 1. Let's do this first. So in order to multiply 3x squared minus 2x plus 5 by 4, I would set up the equation first. 4 times 3x squared minus 2x plus 5. Right there, equals. And then I would basically distribute. So 4 times 3x squared, 12x squared, 4 times negative 2x, negative 8x, and 4 times 5. Which is plus 20. So your final answer would be 12x squared minus 8x plus 20. Example 2. Multiply 5x cubed plus 2x plus 3 by 2. Alright, so once again, set up the equation. And then distribute. So 10x cubed plus 4x plus 6. And that will be your answer. Okay, moving on. Oh, and by the way, the number on the top left corner, it's alluding to these topics. So if you already know a topic, you're already comfortable with it, just skip around, just like take a couple minutes off, and you can just move back to these. Okay, so our next unit or subtopic is adding polynomials. So in order to add 2 polynomials, you have to combine the like terms and expressions. So like terms is basically just variables or what are coefficients to raise to the same power. So for example, let's do these 2. So pause the video, try them out, and then we'll get back to it. Okay, now that you're done, I usually like to rewrite these without the parentheses. It's just a personal preference. You know how to do this. And then you see how these are like terms. I'll be using different shapes for like terms if it makes it easier for you guys. So x squared plus 2x squared, 3x squared. And then triangle for this one. So negative 5x plus 3x, that'd be negative 2x, and then a square. Positive 6, negative 2, plus 4. So that would be your final answer. Moving on. Let's do the same for this one. And then, once again, like terms. Please forgive me if some of my math is wrong. I'm doing this pretty quick. Okay, so you should get that unless I did my math wrong, but it's adding polynomials. Okay, moving on. we'll be learning how to subtract polynomials. Okay, so subtracting polynomials usually requires you to distribute the negative. So you see, for example, right here, this can be considered as -1. So basically what you have to do is multiply or distribute -1 to each of these coefficients in here. So what you get is this, and your final answer would be this. Okay, so let's move on to the examples below. So try these on your own, pause the video, try them out, and then we'll return. Okay, so personal preference again. I usually like to write them out so I don't get confused. Then minus 2x squared. See how I'm distributing? So minus 2x squared plus 4x here, and then minus 3. Once again, combining like terms, it's similar to adding polynomials. So let's change it up this time, circle. Then negative 2x. So 7x squared. And then this one, 7x. And then 4x plus 11x. And then this one, 9, negative 3. So plus 6. That would be for an answer for example 1. Example 2. Oh yeah, distribute the negative. Sorry for not saying it. And combine like terms. So negative 3x squared. And square it. Blah. Yep. And then minus 5x. Negative 6. And positive 12. Which would be plus 6. And that'll be your final answer for this. Subtract the polynomials. Okay, multiplying polynomials. This is a bit of a longer subtopic, I guess, and it's pretty simple. So, in order to multiply polynomials, it would require you to multiply combinations of one term from one polynomial with one term from the second polynomial, and then combine all the products of them. So, the most common type of polynomial multiplication is called multiplying two binomials. The method used to solve this problem is called the FOIL method. So the FOIL method basically stands for multiplying the first terms. So first terms right about here, first terms, this one, 5x and 2x. And then the outer terms after 5x, negative 4. And then the inner terms, 3, 2x, and then the last terms, 3, negative 4. And what you see, if you see my work right here, you multiply all of these and then you add these products, and your final answer would be this. Okay, so there's a condition, there's an exception. So if one or both of the polynomials have more than two terms, then foiling does not work. What you have to do is multiply the first term in the polynomial on the left by all the terms in the polynomial on the right. Then multiply the second term in the polynomial on the left by all the terms on the right. You will repeat this procedure until the last term of the polynomial on the left has been multiplied by all the terms on the right. It sounds wordy and complicated, I know, but it's pretty simple. So let's move on here. There's an example. So this continues, this is a continuation. I'll put an example here. So what this basically said, I'm sorry if you couldn't read it. X plus 3, 2x squared minus 4x plus 5. This is an exception right here. So what you have to do, basically, there's two terms in here. You multiply this by that, this again by that, this again by that, and then you repeat this for the second term, like this with that, this with that, and this with that, and then you get this as your answer. Okay, so once again, pause the video, try these out, and then we'll continue. So 3x plus 1, 5x plus 7. A little tip, by the way, guys. I don't really use the FOIL method. I find it just like weird, I guess. I just do this exception case because it's easier. I don't like to memorize stuff. So so what I usually do is just do the same thing as this. Multiply this by this, this by this, and then this by this, and this by this. But if we're talking about in terms of foiling, I guess I'll just do it in the foiling method. So the first terms in the equation. So first and first. 3x times 5x. So let's label this as FOIL right here, F. Well, that give you 15x squared, okay? And then the inner terms, oh, my bad, sorry. The outer terms, sorry. The outer terms would be this 3x and the plus 7 right here. 3x times 7, which give you 21x. And then inner terms. Inner terms would be positive 1 times 5x. So 1 times 5x, which is 5x. And then the last terms, L, that would be 1 times 7. So 1 times 7 equals 7. And then you would add these. What I like to do is write them out. X squared plus 21x plus 5x plus 7. And then combine like terms. These are like terms. I'll circle them for you. And 15x squared plus 26x plus 7 would be your final answer. Alright, moving on to example 2. Oh, sorry. I need to organize myself really quick. Okay, example 2. This is an exceptional case, so we will do a different method. It's still essentially the same as FOIL, but you know how it is. So what you have to do, distribute basically. X times x squared, bam. X cubed, x times 5x, plus 5x squared, x times 9, plus 9x, and then you do the likewise for the other term. So 7 times x squared, plus 7x squared, 7 times 5, plus 35x, and then 7 times 9, which is 63. Okay, and then once again, combine like terms. So this is just alone, there's nothing else like that. So like term this, 5x squared, like term this, plus 7x squared, and what that give you? So let's rewrite the equation. X cubed plus 12x squared, and then once again, this would be a like term, this would be another like term, plus 44x, and this is just alone, plus 63. That would be your final answer. Okay, moving on. Dividing polynomials. Once again, this is a pretty long subtopic, but it's pretty simple to understand. So this process is basically similar to long division for like basic numbers. So take for example right here, 2x cubed plus x squared minus 11x plus 12 divided by x plus 3. Step 1, you would have to set it up. X plus 3 divided by, x plus 3, and then you just set up in the setup right here. Basically like that. Okay. Step 2, you would determine what you need to multiply by the first term of the divisor, which is x, to get this first term of the dividend, 2x cubed. So what times x would give you this? And that would be 2x cubed. And you would put that over the x cubed little area. Okay. And then step 3, you would have to multiply the 2x cubed by the x plus 3 to get 2x cubed plus 6x, and then place the product under the 2x cubed plus x squared, then subtract and bring down 11x, negative 11x. So it's a bit of a mouthful right there. So essentially what I'm saying is all you have to do, once you get this part right here, you just multiply by this, by that, and this by the 3. And this would be your little like equation that you get, a little formula or whatever. And then you'd have to subtract. So this would cancel out, and then bring down this, which is negative 5x squared. And then you have to bring down the negative 11x. So negative 11x right here. Okay, so continuing. So step 4. So you have to determine what you need to multiply by the first term of the divisor x to get the first term in the expression at the bottom, negative 5x squared. Since you need to multiply x by negative 5x to get negative 5x squared, the second term of the solution is negative 5x. Put the term over the x term in the dividend, multiply the negative 5x by the x plus 3, and place a product under the negative 5x squared minus 11x, then subtract and bring down the positive 12. So essentially, it's a repetition of the last step. What you have to do, once you get this, negative 5x, you multiply this by x, this by 3. And what you get is down here, right here. And then once again, subtract. This cancels out. And this would be 4. Because once again, what you have to do is basically negative 1. And then distribute. So this would be positive 15, essentially. So that would be 4x. And then bring down d12. Okay. And continuing. Step 5, you would repeat the process until the solution is reached. Okay, so this is just the last part. So it's the same as the other steps. So positive 4, right? Times x, positive 4 times 3. And what you get is down here, 4x plus 12. Once again, negative. Oh, sorry, I didn't mention this earlier. You have to distribute, right? But I'm sure you got it already. So it's negative right here, distribute, blah, 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 cancels out. And then this will cancel out. So this means that it has a remainder of 0. Okay. And step 6 is optional, but I highly recommend it if you have an extra time on your test and you just want to make sure your work is 100%. So what you have to do to check your work is multiply the solution by the divisor and then add the remainder to see if the result is equal to the dividend. So basically, if you look, example right here, just look at the, whatever, look at all that over there. And then so x plus 3 times 2x squared minus 5x plus 4 plus 0. And that would give you this, which is the same as here. Okay, so that is it. Okay, so let us do an example. What is the quotient and remainder of the following? 3x cubed plus 8x squared minus 14x plus 13 divided by x plus 4. So, first step, set it up. X plus 4, blah, blah. 3x cubed plus 8x squared minus 14x plus 13. Okay, so what multiplied with x would give you 3x cubed? And that would be 3x squared. And you put that over the 3x squared, the x squared aisle. And the process, step 2, you subtract. Okay, so 3x squared times x, 3x cubed, 3x squared times 4, plus 12x squared, and then close parentheses. What will that give you? Distribute, again, negative 1, distribute, cancels out, and then distribute that, that will give you negative 4x squared. And then you bring down negative 14. And once again, repeat the process. What multiplied with x would give you negative 4x squared? That would be negative 4x. And so, once again, repeat the process. Subtract negative 4x, and that would give you negative 4x squared minus 16x. This would cancel out, distribute, right? This would cancel out. And then this would become 2x, and then break down this, and plus 13. And then, once again, process repeated. Getting pretty repetitious, but it's good for practice. What multiplied with x would give you 2x, which is, it would be 2, just 2, plus 2. Then 2 times x, 2 times 4, you would get 2x plus 8. Once again, distribute the negative 1. This would cancel out, and this would become 5. So in this case, this would be your quotient. And the remainder would be 5, the number below. Okay. Moving on for that. It's right here. Okay. So our next little subtopic. This is unit 2, by the way. Polynomial factoring. Okay, unit 2. So it's greatest common factor factoring. You would also know it as GCF. So GCF is the first type of factoring you should always try. Always. If all the terms of a polynomial have a common factor, that can be factored out. So let's look at an example here, guys. So 6x cubed minus 4x squared plus 8x. What is a GCF of this? Let's see. Let's write it out. That would be 2x because it works out for everything. So 2x. And then what multiplied by 2x will give you 6x cubed? That would be 3x squared. And you repeat the process till you get this. And this will be your final factored form. Okay, so let us do an example. Factor 8x to the 4th minus 12x cubed plus 16x squared. I'll give you, let's pause the video once again. Try it out. And then let's get started. So 8x to the 4th, what is the greatest common factor of all of this? The GCF of all of this would be 4x squared. 4x squared, and then what times what? 4x squared times what would give you 8x to the 4th? 2x squared. And then you repeat the process, and that would be your final factored form right there. Okay, let's move on. So we're going to be learning another subtopic, factoring a quadratic trinomial into the product of two binomials. If the trinomial is of the form x squared plus bx plus c equals 0, you need to find two numbers that add to b and multiply to c. So let's take, for example, x squared plus 5x plus 6. So what two numbers would add up to 5 and multiply to 6? That would be 2 and 3. So what you have to write it out is x plus 2 and then x plus 3. Simple. And let's try an example. So pause the video and try it again. Alright, let's get started. What number would add to 3 multiply to negative 10? That would be negative 2 and positive 5. So negative 2, positive 5. You can write this as x minus 2, x plus 5, blah, 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 blah. And that would be your factor form. Sorry for making it messy. I'll rewrite it. That would be your final factor. Simple. Next one. We'll be learning perfect square trinomial factoring. If in the form x squared plus bx plus c, you can determine a perfect square trinomial if c equals b over 2 squared. If c does equal b over 2 squared, then the expression can be factored to x plus b over 2 squared. So, if c, right here, let's pause the video, try it out. But if c, right here, this is c, if 9 equals b over 2 squared, so 6 over 2 squared, which it does, then the expression could be factored to x plus 6 over 2 squared, which would be x plus 3 squared. That would be your final. Simple. Okay, next unit, our subtopic, is the difference of perfect squares factoring, otherwise known as DOPS. An expression like x squared minus 5 squared is known as DOPS because each of the terms is a perfect square and there's a subtraction sign in between, like this, right here. In general, the expression x squared minus a squared can be factored into x minus a and x plus a. So try this example and then we'll still get started. Okay, so let's get started. Basically, 81 is this could be rewritten as 9 squared. X squared minus 9 squared. And this follows the formula x squared minus a squared. So what that can be factored into is x minus 9 and x plus 9. That would be final factor. Okay. The next unit, factoring cubic expressions by grouping. Factor by grouping takes place when you have a 4-term cubic expression and you factor a common factor from the first 2 terms and another factor from the last 2 terms. It's pretty simple, really. So let's do this example together. So let's group it up, actually. First 2 terms and then last 2 terms. So what is the GCF of x cubed minus 3x squared? That would be x squared. And then you take that out, x minus 3. And then you do the likewise for this. What is the GCF of 4x minus 12? Which would be 4. That would be positive. X minus 3. You see how these are similar? And you can just group them by this and this. So x squared plus 4 and then x minus 3 will be your final answer. Okay. Moving on. Algebraic identities. Proving that something is an identity requires you to simplify one or both of the sides of an equation until the 2 sides are identical. Until an identity is proven, there will be a little equal sign with a question mark on top of it sign. When it is proven, the sign will be replaced with a check mark, an equal sign with a check mark. Okay, so let's do this example. X plus y squared minus 4xy with the little question mark, x minus y squared. So what you have to do is just factor them out, essentially. So this will turn into x squared plus 2xy plus y squared minus 4xy equals question mark x squared minus 2xy plus y squared. And then finally the answer you would reach, the final answer, they're identical on both sides. So this can be proven. This is an algebraic identity. Moving on, the remainder theorem. If you divide fx equals x cubed minus 5x squared plus 6x minus 3 by x minus 4, you get x squared minus x plus 2 remainder 5. The remainder theorem states that you will also get a remainder of 5 if you substitute the opposite of x minus 4, which is positive 4, into x cubed minus 5x squared plus 6x minus 3. So this is just basically plugging in. If you get, let me explain this better. If you divide this by this and you get a remainder of 5, the remainder theorem itself also states that you would also get a remainder of 5 if you substitute the opposite of x minus 4, which is positive 4, into the equation that you solved, which is this one right here, and you get the same remainder. Likewise, the factor theorem. So it's basically like a little continuation of the remainder theorem. It's basically essentially similar. The theorem states that if x minus a is a factor of f of x, then the value of the polynomial when positive a is plugged in would be 0. So I'm not sure if you get it or not. So if you say you have an equation f of x, right? And then you divide x minus a, right? Divide this divided by that, right? And if you get a remainder of 0, that means you're like a factor. That means this would be a factor of this if you get a remainder of 0, because it works out perfectly. So essentially, it's just a continuation of the remainder theorem. Like if you plug in the opposite of this, which is positive a, you would also get a remainder of 0. And then a new topic. It is polynomial equations. So solving quadratic equations that have no x term. A quadratic equation is one where the largest exponent is a 2. The simplest type of quadratic equation is when there is no x term, like x squared equals 9. The solution will be solution set. This is solution set, by the way. 3 and -3. Because since let's show us a little work then. So square root that to negate this. Bam. X equals plus or minus 3. Because it's just how it works. So, solving factored polynomial equations. The quadratic equation x minus 2 times x plus 3 equals 0 can be solved quickly. Equations similar to this can only equal 0 if one of the two factors also equals 0. So, example, like here, x minus 2 times x minus 3 equals 0. You set these both to 0, and the solutions would be 2 and 3. If you just treat these as like little independent little equations. So plus 2 right here, plus 2, plus 3, plus 3. And this will cancel out. You get 3 here. This will cancel out. You get 2. So x equals 2 or x equals 3. And then you write that out in the solution set. 2, 3. Alright, try it out for this. What is the solution set to x minus 1 times x minus 3 equals 0? And we'll try it out. Okay, so since this is set to 0, it's quite an easy equation, I guess. And x minus 1 equals 0, and x minus 3 equals 0. Sorry, x equals 1 and x equals 3. And that would be your solution set. Oh, sorry, I forgot to write it out. Bam, so right there. 1, 3. And then we'll move on. Solving quadratic equations by factoring. Set the equation to 0 to find the solutions easily. Alright, sorry. Let me check something. Okay. So essentially, you have to factor this one. This is an extra step from the one before right here. It doesn't give you like this. You have to find this like form yourself. So let's see right here. X squared minus 5x plus 6 equals 0. How would you find that? So what adds to -5 and what multiplies to 6? That would be -3, -2, because the negatives cancel out. So x minus 3, x minus 2 equals 0. And once again, it's like this, like the form right here. So you set each of these to 0. X minus 3 equals 0, and x minus 2, x equals 2. And the solution set would be 3, 2. Okay. And let's move on to the second example. So try it out yourselves and we'll return. Okay, so this is a little different since it's not set to 0, but it's easily solved. So what you have to do to get this side to 0 is subtract it by 5. And this would be x squared minus 2x minus 8, which equals 0. So once again, the process repeats. What do you have to multiply to get -8, and what do you have to add to get -2? And the answer to that is 4 and -2. So x plus 4 and x minus 2 is equals 0. Once again, pretty easy, and write it out. Oh, sorry. I made a mistake. Forgive me, guys. The signs would be opposite because you want to get a -2 instead of a +2. This would be -2, this would be +4. So there we go. Okay, moving on. Solving quadratic equations with the quadratic formula. Two solutions to the formula, ax squared plus bx plus c equals 0 can be found by the formula x equals -b plus or minus square root of b squared minus 4ac over 2a. Little word to the wise, guys. It's really helpful if you just memorize this straight up. Just memorize it, keep it in your head, and it'll help you throughout high school and stuff. It's pretty easy. So what you have to do is, since this is in the form a, so this is a, this is b, this is c. What you have to do is -b, so -4, which would be -4 plus or minus -4 squared minus 4 times 1 times 1. And you set that all over 2 times 1. Okay, so solving this out, 4 plus or minus square root is 16 minus 4 over 2, which equals 4 plus or minus 12 over 2. And if you want to simplify this, if you want to simplify that, the square root of 12 would simplify to 2 radical 3 over 2. And then you just simplify these. So 2 and then out. So 2 plus or minus square root of 3 for your final solutions. And if you want to write that out in a solution set, it would be 2 plus radical 3 and 2 minus radical 3, since the plus and minus are here. So once again, be sure to memorize this. It's pretty helpful if you do. And let's continue. So lesson 5, a new topic, guys. So right here, quadratic graphs. So subtopic, quadratic graphs. Alright, so the most basic quadratic graph is y equals x squared. By plugging x values into the equation, it produces ordered pairs of graphs. So let's say I want to plug in x equals 1. So like ordered paired 1, and then plug in 1, 2, 4. And those are like pairs to graph. In this case, the graph of y equals x squared produces a U shape. It's called a parabola. The lowest point of the parabola, which is 0, 0 in this case, is a vertex. So a little graph I made. So this is it's not as accurate, but you get the shape, the parabola, lowest point, vertex, 0, 0. And that's it. Moving on. So this would be changing the a coefficient. If a coefficient greater than 1 is in front of the x squared, it becomes narrower parabola than y equals x squared. So like if, let's say y equals x squared like this, like a brief little sketch, then y equals like 2x squared would be a little narrow, like that. You know what I'm saying? And the coefficient is called a, and the equation becomes y equals ax squared. If a is negative, the parabola will be reflected over the x-axis and resemble a like downwards U shape, so like this, if a is negative. Like that. Okay, let's move on. This is the vertex form of a quadratic equation. So let's see. This would be the basic like vertex form formula would be y equals a times x minus h squared plus k, where hk is the vertex. So let's try an example right here. Right there. Yeah, okay. So basically x minus h, and that perfectly makes sense because the vertex will be 2, right? And since it's plus k, but this is negative 5, this would have to be negative 5 because the original formula is plus k and minus h. Okay, move on. Graphing quadratic equations. To sketch more accurate graphs, you can find x-intercepts and y-intercepts. X-intercepts are found by setting y equals 0 and solving for x, and y-intercepts can be found by setting x equals 0 and solving for y. It's pretty simple, basically. Okay, so, and then, oh, little follow-up actually. So, actually, you know what? I think you got it. So like, let's say like y equals like 2x squared plus like 5x plus 6. To find the x-intercept, set this to 0. And just solve for x. That's it. So moving on. The standard form of a quadratic equation. So the standard form is in the form ax squared plus bx plus c. That's the standard form right there. And to find the x-coordinate of that would be negative b over 2a. So negative b over 2 times a. And the y-coordinate of that is when you just plug in the result of this. You know what I'm saying? So like you plug in the numbers, right? You get this as x, but then you plug in x coordinate again back into the equation to get the y coordinate. That's essentially what it is. Okay? So, moving on. So, let's move on. Just a little note, all the stuff done before, like graphing quadratic equations in the graphing calculator, just graphing quadratic equations straight up, can be used by using a graphing calculator. So for a graphing calculator like mine, TI-84, TI-84 plus, whatever, turn it on, go to y equals, and then plug in like a formula. So 2x squared plus 5x plus 6, and then set the equal, and then so if you want to reset like the graph, because I had a weird window, you just do zoom and then 6 Z standard, and there you go, parabola like that. Okay, so just a little tip, and let's move on to focuses and directrix of a parabola. So in the form y equals ax squared plus bx plus c, or y equals a times x minus h squared plus k, the distance between the focus and the vertex, or between the vertex and the directrix, is equal to 1 over 4a and is labeled or connotated with the variable p. So, little tip, I forgot to write it down. The focus and the vertex, the distance between those are the same as the distance between the vertex and the directrix. And so p equals 1 over 4a. So this would be equal, this distance right here, as this one right here. Distance. Okay. And so we're on to our final topic. So polynomial graphs. These are essentially really easy. It shouldn't take that long. So what do you have to graph? Basic cubic functions or equations. You have to find the x and y intercepts and connect them with a little like N shape, I guess. If a is positive, this would be this, and if a is negative, it would be like a backwards N, or like a upside down one. And little exception right here. If there is a double root, like if you do x minus 2 times x minus 2 times x plus 3, this is the double root kind of the way, the curve bounces off that point. So that's all for today. Thank you for watching the video. I'm John Kim, and next, I think Wednesday, not next Wednesday, this Wednesday, I'll be releasing lesson 2 of the Algebra 2 series. Okay, thank you for watching.